training. My name is Tanner Gibb. I am a senior associate education and research scientist in our research and development team. I know that's a very technical title. It means that I know a lot about this device and the science and the technology that goes into it and our products. So today I have the absolute privilege to do a training on PRYSM IO, talking about improved precision and being a training on accuracy. So we're going to define those two terms, why they're relevant, why they're important, and all the work that we've done to make PRYSM IO as accurate and precise as possible. A little bit of background before we jump in. It's important to understand what's being measured. So PRYSM IO measures small compounds called carotenoids in a very large matrix of the skin, which has many, many other compounds. Carotenoids have unique light filtering properties, which allows them to be estimated with certain spectroscopy-based technologies, including hyperspectral absorption that we'll get to. Examples of common dietary carotenoids and their chemical structure include lycopene, lutein, beta-carotene, astaxanthin, zeaxanthin, and there are many others. Carotenoids are very bright pigments that provide a lot of the yellows, oranges, and reds to many fruits and vegetables and other foods. They're also found abundantly in many leafy greens like spinach and kale. And these carotenoids are a good indicator of fruit and vegetable intake and our antioxidant status. In addition, because of their chemical structure, as you can see here, they have these alternating single double bonds. They call them conjugated double bonds in chemistry. But what it allows them to do is act as these super antioxidants, but number two, be able to be estimated with different light-based measurement technologies because of their ability to actually absorb some of the light within that visible spectrum. In terms of that application for PRYSM IO, we use what we call hyperspectral absorption. Now, let me see if I can explain this well. So inside of the PRYSM IO device, we have two different photodiodes. We have photodiode 1 that measures the light intensity coming out from these range of LEDs, and then photodiode 2 that measures the light intensity that is reflected back into the device. Now, what we care about and what's important for this measurement is the absorption of some of that light, hence the term hyperspectral absorption. Because we know that carotenoids have those unique properties, they can actually absorb some of that light within that visible light spectrum. And based on that, we actually selected the LEDs and created the specs and the components inside of the device to be able to measure that difference in absorption between photodiode 1 coming out and photodiode 2 light intensity reflected back. But it's not just a simple equation, so to speak, okay? We have the difference in the light intensity going out and coming in, but what we've also done with this technology is compare that to the proprietary Raman technology. Now, for those who know, we've been using resonance Raman technology with our biophotonic scanner with the S1, the S2, and the S3 versions over the years. Now, with that technology, it is a little bit different, where you're measuring a specific wavelength of light, and you're capturing the intensity of a shift in the energy of that light coming back into the device with the biophotonic scanner. Whereas with PRYSM IO, it's more about the reflection of the light coming back and calculating the difference in what is actually being absorbed and what is coming back into the device. That being said, we've been able to compare PRYSM IO with our biophotonic scanner and the scores, et cetera, and look at many different machine learning models. In other words, AI algorithms that look at all of this data and all of these scores to be able to correlate something that means that the PRYSM IO is going to score very, very similarly to the biophotonic scanner. Okay, that's what this algorithm is doing, and that's why it's capturing the technology from the past with a new technology applied with PRYSM IO. How do we know if PRYSM IO is accurate? Well, when it comes to accuracy, this is how close to the target you are. I like to use the example of a bow and arrow, right? If you shoot a bow and arrow at a target, you want to be as close as possible to the bullseye as possible. That's going to be how accurate it is, how close you are to the target. Precision is how close you are around a particular target, right? So precision and accuracy both matter. But in terms of accuracy, what we want to do and what we want to look at is with PRYSM IO, we're measuring or estimating carotenoid levels on the skin. Well, how does that correlate to serum or blood levels of carotenoids, which are the indicator for fruit and vegetable intake. Now, what we did is a large study with 97 individuals with different skin types, taking a PRYSM score and a serum level of carotenoids and looking to see if we can find a correlation. And the results were absolutely phenomenal here. As you can see, right, each individual plots out their PRYSM score and their serum levels of carotenoids. And you can see that based on this clinical study, there's a very strong correlation between the PRYSM score and serum levels of carotenoids with an R-squared value of 0.77 and an R value of 0.88. In statistics, if I can try to explain this simply, R-squared is a matter of one variable being able to predict another. In this case, PRYSM score being able to predict serum levels of carotenoids. And secondly, R is the correlation coefficient. What that means is the strength of the correlation between the two values. So pretty much you have one that is predictive in nature and the other that is correlatory in nature. Either way, these numbers show a very strong, positive, direct correlation between what we measure on the skin with PRYSM IO and what's actually found in the blood. So this really eliminates the need to be able to do something invasive that is more costly, etc., and replace that with PRYSM IO that is non-invasive, that is quick, and very accurate in its ability to actually measure carotenoids on the skin as a good biomarker of the serum levels that are actually found inside of the body. So number one, this confirms that what's happening in your body, we can actually measure with good accuracy because of this very, very strong correlation that we note in this clinical study that has been published. What about precision? Like I mentioned, accuracy is how close to the bullseye you are, right? The bullseye being serum levels of carotenoids. And then precision is how close around that bullseye can you be on a consistent basis. So when it comes to precision and variability, look, all equipment is subject to this, okay? It's not a question of whether there's going to be any variation. It is a question of how much variation is going to exist. Now, variability can be reduced and managed through proper usage, maintenance, and calibration. This is why we focus so much on improving precision, because we already have the validation study that proves accuracy. What do we do about precision? We need a little bit of context here. There's so many biological measurement devices in the marketplaces. Wearables, for example, are all over the place, right? From rings and watches, etc. And there was a nice published review that looked at precision or variability of these wearables and looking at different metrics, so to speak. And I jotted down a few of them from this study. Heart rate, 6%. Step count, 21%. VO2 max, 30%. Energy expenditure, or how many calories you burn, 35%. So estimates are all over the place, and they may not be as precise as what you might think or expect, but that's what the research shows. Same thing with a glucose monitor, 9 to 12%. But you compare those things to the biophotonic scanner S3, 6 to 8%. PRYSM IO, 5 to 8%. So when we put these things in context, we can see really good precision with PRYSM IO compared to some of the common wearables that we see in the industry. IO 5 to 8% and the biophotonic scanner 6 to 8%. They came from this really well-designed, controlled clinical study. Now I'm going to go over the results for PRYSM IO and leave aside the results for the scanner. However, note with a biophotonic scanner, we noted very similar variability, 6 to 8%, compared to what we saw with PRYSM IO, 5 to 8%. So this is an internal study, 39 subjects, 5 PRYSM IO devices. So the methods, they scanned 3 times each on 5 PRYSM devices. They repeated this on 3 different days. So we get over 1,700 data points. In other words, 45 scans per subject. That's a lot of scans. The purpose was to examine variation between scans and sessions on the same device, but also across different devices to see how precise the device is. And these are the results. And these results were absolutely phenomenal. Within device, relative standard deviation, which is a term in statistics that shows kind of the normal expected curve or margin for determining where your scan is going to land within device relative standard deviation is 5.55%. The across device relative standard deviation is 8.58%. What does this mean? In controlled settings, and I want to emphasize this, this is an internal study that was run with experts on the PRYSM IO who are very particular about how the scan is being conducted, following all of the best practices, making sure every scan is done accordingly. And we'll talk about that in a bit. But what this means, PRYSM IO has approximately 5.55% variation in scans on the same device. PRYSM IO has approximately 8.58% variation across different devices. What this means is that we see better precision on the same device, and we see a little bit higher variation across different devices, but both of these values are actually really, really good in terms of precision. Let's talk about PRYSM. It is marketed to have an acceptable device variability of 30 to 50 points by following best practices. Okay, that's based on the clinical study and the research that we've done that I just showed. So a very, very small difference in points you can expect to vary slightly from each scan. However, from field use, most scans fall within plus minus 10% when scanning on the same device. So in controlled conditions, we see better precision compared to what we see in the field. Let's give an example. If your true PRYSM score is 500, and by true PRYSM score, I'm referring to if you were to scan a bunch of times and taking the average of that, you get close to your true score, okay? Well, plus 10% of that is going to be 550, and minus 10% would be 450. So in terms of that average score, you can see that there's going to be a rough range of about 100 points, okay? 50 above, 50 below. It's going to be a little bit different in terms of variability when we have higher scores versus lower scores, but this is going to be a good rough average to see how these things shake out in terms of variability with normal expected scans. Take another example. If your average score is 350, which is in the mid-yellow zone, most scores should fall within plus minus 10%, which is 315 to 385. You can see it's a little bit tighter in that window for that percentage in terms of the absolute score compared to higher scores. That's it. In simple terms, this is generally plus or minus one color shade. So what does that mean, right? If you fall at 350, that's going to be your average score right in the mid-yellow. Well, we expect most scores to fall within plus or minus one color shade. And that is going to apply across the spectrum generally for most scans, maybe except for the highest scores, which has a wider range in terms of absolute score. But for most scores, you're going to see that plus or minus one color shade. That explains most of the variability that we would expect for scans that are done using best practices. Now, in stats, this phenomenon of variability around the average is called a bell-shaped curve or a normal distribution. So what this means is that most scans are going to be close, plus or minus one color shade, to your true score. However, a small percent of a person's scans have the potential to be further away from the average than the expected variability. These results are what we call outliers. So as you can see here on this graph, you have this normal distribution curve. You can see that most scans are going to fall around that 350 mark. Some are going to be a little bit higher, some are going to be a little bit lower. But if it's falling outside of that plus or minus one color zone, right, getting into the green and the orange, etc., that's where they're going to fall into outliers. And in statistics, outliers are things that we're going to ignore because they're not really representative of your true actual score. So what do we want to do? To minimize outliers and have the most precise results, we want to follow best practices. And for this, we divide it up into the 3 Ps. Okay, we have prep, pressure, and position. First, prep. You want to wash and dry hands before each scan. You want to wipe the lens clean with a microfiber cloth before each scan. You want to calibrate on a regular basis, especially if you're traveling or have different lighting or different environments. You really want to calibrate on a regular basis to make sure that the unit is functioning as well as possible in the different environments where you're scanning. Pressure. Apply gentle, even pressure. So this does not mean hard pressure. It's a very light amount of pressure. You want to fully cover the lens with the finger to avoid light leaks and use the same finger on each scan. That's important because different fingers might have a different distribution of carotenoid levels. We know that carotenoids have uneven distribution throughout the entire body, including the skin, including different fingers as well. So be precise in using the same finger for each scan. Position. You want to place the device on a flat, level surface. You want to scan indoors, avoid bright lights, and don't move the finger during the scan. Hold still. That's only a 15-second scan. If I could summarize these into the big three, what are the big three that are going to create a bad reading? Number one, you're not cleaning the lens after each scan or before calibrating. Number two, you're not cleaning the finger before scanning. And number three, improper finger placement or pressure that can lead to light leaks or pushing too hard. Yes, there are other variables at play, right? Scanning the higher low temperatures, not on a flat surface, using different fingers, a device not calibrated recently, etc. But the big three, if you can just focus on those big three, make sure that you clean the lens before every scan and before calibrating, right? Clean your finger before each scan and make sure you have the proper finger placement and pressure. Those three things are going to be the biggest variables for giving you the most precise scan each and every time. Now, it's really important to consider this device and statistics when we talk about what criteria we want to focus on and what criteria we don't want to focus on. And what I mean by that, look at this hypothetical example. Let's say an individual just started taking LifePak and you get your PRYSM score every week. The trend or the pattern is much more important than isolated scores. As you can see here in this example, at baseline, after week 1, it goes up a bit. Week 2, it drops down a bit. Week 3, it goes up. Week 4, it stays steady. Week 5, it goes up. Week 6, it drops a bit. And then what happens there at week 7? Okay, you get a drop that maybe just doesn't make sense. Okay, now this drop is what's going to be called an outlier. And when that happens, number one, we want to reemphasize the importance of following best practices because it could be possible, right? You didn't clean your finger, you didn't clean the lens, it wasn't calibrated, you had the improper pressure, right? All of these things may have contributed to that drop. But if you are following best practices, it still is possible to see outliers on occasion. And so when that happens, we ignore that result in stats and we focus on the trend or the pattern over time. As you can see after week 7 on week 8, right, it jumps back up to that normal linear response that we generally see in that trend or pattern. Week 9, week 10 continues to increase. Week 11 looks a little bit steady. Week 12 continues to increase, okay? Now, this is important. It's all about the trend or the pattern, not isolated scores. So what do you do? If someone's score seems a little bit too high or maybe too low on the scale, it just doesn't add up. It doesn't make sense, okay? Well, our recommendation to you would be scan 3 times on the same device to get the best average. When you scan multiple times on the same device, that helps to minimize the effect of an outlier, right? Because it's all about the average, and the more you scan, the closer you get to that true score or that true average score that you have. Number 2, recommit to following best practices. I want to emphasize this over and over again, okay? Based on our clinical study, when we follow best practices, we see really good variation, right? In that 5% scale, which is really small numbers, right? About 30 to 50 points, no more than that. 3, recalibrate as needed. This is going to be an important thing, especially with different environments, et cetera. You want the device to adapt to where you're going. And so you want to recalibrate as often as possible to make sure that you're getting the most precise results. Number 4, track on the same device. As I mentioned before, tracking on the same device is going to give you better numbers in terms of precision compared to tracking on different devices. Let's look at this example here, right? If you were to scan over 100 times on the same day, using best practices, most scans are going to fall within a normal range or a normal distribution. As you can see here in this example, it's a range of about, 350 to about 440-ish. And you can see most of the scans are going to fall really tightly around that average of about 400. Some are a little bit higher, some are a little bit lower. And on occasion, we are going to see a few outliers, which, as I mentioned, outliers are things that we ignore. These are things we're going to put aside because they're not reflective of your true score, whether it be a bad scan because you weren't following best practices, or you were following best practices and it just happened to be an outlier because we're measuring carotenoids, which are small compounds, in a very complex matrix, which is the skin, which has many, many other compounds. It's a very detailed detection practice to be able to minimize the other stuff and focus in on these carotenoids, which is the purpose of this device, to be able to measure those with accuracy. Why is my score different on different PRYSM devices? Well, we want to recommend, firstly, scanning on the same device for the best results. That is always going to be our standard recommendation. The same device has less variability, in other words, better precision, than across devices. However, number two, we would recommend calibrating each device. Make sure the calibration disc is not scratched, damaged, or discolored. Use the calibration check feature in the PRYSM IO app to make sure the device calibration is good. Replace the calibration disc if it is damaged. And when in doubt, just recalibrate the device. Make sure that it's calibrated on a frequent, regular basis for best results. Number three, take multiple scans on each device to have a better comparison. As I mentioned before, isolated scores are going to vary a little bit more compared to average of multiple scans because you get closer to that true score, that true average with multiple scans compared to just isolated scores. A little bit of a summary here. PRYSM IO is a high precision device that should be stored and cared for to get the best results. It's not a toy, as we like to say. Biological measurement-based equipment is subject to variability. It's not a question of if it's going to have variability, it's a question of how much, as we talked about with wearables and other devices that exist. PRYSM scores correlate strongly with serum carotenoid levels. This is confirming the accuracy of the device, right? It's all about that bullseye, trying to get as close as possible to your ultimate goal. This confirms that the algorithm that we apply with PRYSM IO is very accurate in its estimate of skin carotenoids because of that very strong correlation. PRYSM scores in the field generally have plus minus 10% variability, which is close to plus or minus one color shade of your true score. As I mentioned before, right, it's marketed to have that 30 to 50 point range when following best practices. That's what we see from our clinical settings. And it's going to be a little bit higher, closer to maybe that up to that 80 to 100 point score variability when we see scans and we measure and look at the research of scans in the field. So in general, this is about plus or minus one color shade of your true score. That's a good, easy way to gauge if most of your scans are following where a normal distribution where they should fall. Follow best practices to minimize outliers. I cannot overstate that. Please follow these best practices, especially the big three that I mentioned, right? You want to clean your finger, you want to clean the lens, and you want to use the right finger placement and pressure. Those three, those are the main things to follow each time. And then the trend or pattern over time is more important than isolated scores. Okay, it's about the trend, it's about the averages. That's what we want to look at in stats. And what's so incredible about all of this is with PRYSM IO, right? It's measuring this class of carotenoids. We know that carotenoids are super antioxidants. We know that they're a good indicator of fruit and vegetable intake, but also based on our research and our evidence, we see that there are many other dietary and lifestyle factors that have correlations to your PRYSM score. And so you can use this on a regular basis to be able to see aspects in your diet, in your supplementation, in your lifestyle that you want to improve or that you want to change to be able to see the changes that you really want to see in your life. So with that, I think that is the end of my training. Thank you so much for listening. I hope you learned a little bit something about variability in terms of accuracy, how close we are to that bullseye, and precision, how consistent we are around the target of measuring these incredible antioxidants and for all the benefits that they provide. So thank you so much today.